Hello, welcome to Coding on Crack. Today, we're gonna look at the basics of Core ML for computer vision applications. This is essentially going to require that you already have a .ml package or an ML model that you want to use in your app. So if you don't, go check out this video in order to learn the basics of how to train and export image classification models for iOS. Then this video is going to go through the basics of the vision framework, of the Core ML framework, so that you can understand the underlying principles that are necessary for running these Core ML models and then apply it however you want. All right, here's the little example app that we're going to put together. Essentially, you'll have this screen where you can use live inference to predict what a Pokemon that your camera is looking at is. And then you'll also have the ability to come to Photos, select a Pokemon, and it'll run the single image inference on whatever picture you upload. Okay, so before we actually get started with the Core ML concepts, if you want to use the camera, which we're going to be using in this app, and for any computer vision project, you probably will want to use a camera, you're going to need these three, or one of these three require keys in your Info.plist. So first one, NSCameraUsageDescription, essentially just allows you to access the user's camera. PhotoLibraryUsageDescription allows you to access their photo library so they can go in and select photos they might want to run inference on. And then PhotoLibraryAddUsageDescription allows you to save images to the user's library. So just copy over whichever ones you will actually need. If you do not have one that you do need, or you write code that's trying to perform one of these actions, then your app will crash. You're essentially just going to copy one of these guys, one of those keys, and I'll have these keys and the example descriptions down in the description below. But you can grab one of those keys, come into your project, go to your project, go to your target, and then go into your Info.plist file, and then come down here. You see I already have the photo library additions usage, the camera usage, but let's say I get rid of this one. You're gonna hit the add button, just paste that NS camera usage in there, and then add your description for illegal activities. And then that's the message that they're going to see in their app when they allow camera, when the app essentially requests to be able to use the camera. So run through, throw those guys in there. And then next we're going to look at the actual principles of Core ML. So let's start by just looking at the overall layout of this app. You'll have access to all of this code in the description below, so you can look through it and understand how everything works. Essentially what we have is, or use that code if you want, but essentially what we have is our inference service. That's where all the magic happens. Our inference service is used in the camera view controller, where that camera view controller and this camera container are being used to run the live classification view. The live classification view is that live feed where you're able to see real-time predictions being made. Then we also have our image classification view where you're just uploading a picture, and that also directly uses that inference service. Now, and then those are both just in a tab view and in the content view. So if we come back to our code, we can see all of this. We come into this content view, our selected item, photo picker item, our selected image, our photo result are all being stored in that content view. And then in here, you have the option to look at that live classification view. This could be a tutorial all on itself, just how to run live feed inference. So we're not going to focus on that so much in this video. Let me make myself a little bit smaller. There we go. But that essentially uses this live classification view and utilizes a camera view controller that outputs basically your result as you're feeding those live feed images into your ML model. Then the other kind of main source that we have is this second view, which is essentially just allowing you to upload a photo and see what the result is. Now, if we come into our inference service, this is what I really want to focus on teaching you today and showing you how this works. This is essentially just where we're actually running that .ml package in our in our code. So you've downloaded your folder, which your artifacts folder, which came from our training and export pipeline. You then take your .ml package, you drag and drop it into here, and that's going to come in as this image class ResNet file. You can obviously rename that if you want to. Now, Xcode is going to automatically generate a class for your ML model. So you're instantly able to use that in your inference service without developing that yourself. And I'll show you essentially what that looks like right here. Image class ResNet, that's that model. You're able to initialize that model with all of its weights and parameters in your code because Xcode automatically generated all of this code for us, which is super nice. If you come into your actual model, you're able to get some information about it. You could create your own description, your own author license version, blah, blah, blah. I highly recommend using versioning, using some kind of versioning system so that you can track the performance of different models with different training data sets or different parameters, but that's a topic for another video. You can also see all of your class labels over here. You can see essentially how it's being computed. You can look at your predictions, what are your outputs, what's your input, which is super performant. You can see, okay, the input here is color 224 by 224. You can run performance tests. You can actually look at the structure of your ML model architecture, which I think is super cool. Now, this is all like way beyond the scope of this video. This is like crazy linear algebra type shit, so we're not going to worry about this, but it is really cool if you ever want to like learn how these models actually work. And then utilities, encryption keys, whatever. So in our inference service, I am essentially initializing a singleton inference service because that gives us, let me see this over here. So singleton gives us one global instance throughout our entire app, which means it's easily accessible from anywhere in our app, and it minimizes model reload per view. So if you look at its initialization function, you're initializing your ML model every time you initialize this object. Since we use a singleton, that object only gets initialized once, the first time it's used, and then never again. So that's going to minimize the overhead you get from initializing your model. Now, you could also use dependency injection. Again, that is a topic for a whole other video. So that's why we're creating a singleton. Then this VN Core ML model is a special class that handles computer vision specific tasks for ML inference. It handles things like automatic orientation management, color management, and it's optimized for certain input-output types that are directly related to vision tasks like CG image, CV pixel buffer, all that kind of stuff. Then you'll see right here, we are creating a dispatch queue, and we're also tracking, is this running live? This is essentially tracking, is this model being used in a live feed, video feed context or not? And then this request queue is allowing us to run our requests on a background thread. And again, another topic for another video, but these background threads essentially execute code somewhere other than the main thread, where the main thread is basically the code being executed for UI updates and UI responsiveness. Now, if we come into our init, we use some default model configuration. We tell it, hey, this essentially says, use whatever resource the device has that is best for processing ML operations. This should kind of be your like default go-to unless you have a really good reason to do something else. Then in here, we're going to try and load the model in. If we fail to load the model in, then we're going to throw a fatal error and the app is going to crash. The reason you can do that here is because you want to make sure that the model that you have in your app is going to work 100% of the time. So if you ever run this during testing and it crashes, you have a major issue. That should never fail. Then within the context of this do block, we're going to create our actual ML model using that default configuration. Again, this is the ML model that we trained. And then we're going to get that architecture and we're going to convert it into a Vision Core ML model, which again is just a wrapper around that ML model to make it easier to use images images and do vision-oriented tasks. And then right here, you can edit this if you want to add any other kind of debugging print statements to get information about that model. Then we have two functions down here. We're going to focus more on this classify function because the live frames classify is a little bit more complicated. But essentially, this function is going to run classification on video frames, and then after it gets each result from each video frame, it's going to send that result out through this escaping enclosure. If you look at where this is being called from, you can see that this camera view controller is calling that classification, sending in the pixel buffer, and then it captures the results of that classification. And then on classification, it's returning that result so that the live feed view controller can capture that result and assign it to our text view that's actually in our live classification view. Then for running still images, we'll walk through this a little bit more slowly so you can understand each little component. The first thing we're going to do is get the CG image from the image that we're passing in. On the UI side, we're obviously capturing a UI image. That UI image is easily converted into a CG image. CG images are used as input to VN Core ML request handlers. So let's run through these notes real quick. We've talked about singleton, what a VN core model is, why we're using that dispatch queue. Now, these two guys sound very similar, but they're a little bit different. A VN core ML request is essentially stating, here's what we're going to run. So you have your model that you've wrapped in your VN core ML model. You have any options that you've set. So one of those options would include this line of code right up here saying, okay, our compute units is .all. Let's just grab the optimal CPU or GPU or processor to run this ML model, as well as our actual completion handler. Then the VN image request handler actually executes the request on input images. So as we can see up here in our request, we're defining our request in this live feed function. We're defining our request, we're passing in that model with all of those options, and then we're saying, hey, once you get a result, here's what you're gonna do. Now we're just defining in this enclosure what it's gonna do once it gets its result, but we're not actually doing it. Then when we run the handler, this is the VN image request handler, that's where we pass in our arguments and we actually get the result of that request. And then this code will actually be executed once that handler is run. So it's kind of funky how that works or how those work together, but once you understand what's going on, it's not too hard. In this case, when we define our VN core ML request, which remember is just what to run, all we're doing is passing in the model, which means we're just going to get the result, but we're not necessarily telling it beforehand what to do with that result. That way, once we do get the result from our handler, we can actually just grab that data and do something else with it. Now, when looking at this handler, you have two possible input types. If you're doing live feed video frames, then you'll be passing in CV pixel buffers. And if you're just doing a single image, then you're going to pass in a CG image. Finally, our VN classification observation, which is this right here, is the result that comes as a output from actually running inference on one of these inputs. And that result is going to be sorted by prediction confidence. So you'll have an array with your most likely class, let's say class A, and its prediction confidence, and then class B and its prediction confidence, and it's going to be decreasing as you go down in its confidence because it's sorted according to how confident it is of each prediction. And that's what we do here is we essentially just pull that out and then we return the best possible, the most likely class prediction. And then back in our content view, we just display that to the user. And that's essentially it for this video. I hope you enjoyed. Check out all of the information in the description below. It's got code, it's got more code, it's got instructions, it's got those plist values, and yes, like, subscribe, and do other things that are beneficial. Oh, comment. And by comment, I mean tell me what other topics you would like covered, especially if they're topics that I briefly mentioned in this video and was like, hey, this should be a topic for another video, then tell me to fucking make videos about those topics, because I want to make things that you want me to make. All right, adios. Have a good day. Bada bing, bada bang, bibbidi bobbidi beachy.